Good time of the day, everyone. Welcome to the first session here, which is on Human Aspects 1. My name is Alexander Serebrenik. I am from Eindhoven University of Technology in the Netherlands, and I will be chairing this session. We have 7 very interesting presentations in this session. And if you have any questions during the session, please do not hesitate to post them anytime during the talk using the Slido app on the left-hand side of the screen. If your question is not answered during the presentation session itself, it will be moved to the individual chat box of the paper so that you can continue the discussion. And of course, you can also use Slack. Without further ado, I would like to introduce the first speaker of today, Margaret Ann Story, who is going to talk to us about a theory of software developer job satisfaction and perceived productivity.
Thank you, Alexandra, for the introduction. I will just share my screen. So today I have the pleasure to present a short presentation on a journal paper, which is joint work with Thomas Zimmerman, Chris Bird, Jacek Czerwonka, Brendan Murphy, Irini Kaliamvaku. And this is a paper describing a theory of developer satisfaction and productivity. And this journal first paper appeared in the IEEE Transactions in Software Engineering. So this research started from a sabbatical that I spent at Microsoft back in 2017. I spent several months with the 1ES team there. This team is responsible for engineering the system that is used by almost all of Microsoft. And they were interested in understanding how their engineering system impacted satisfaction and productivity of developers. But of course, they were also interested to know what other factors could impact their productivity and satisfaction. So understanding job satisfaction and job performance has been a topic for research for some time. And in fact, early research considered that there perhaps was not a relationship between the two, or that there was a unidirectional relationship. But more after some years, Judge et al. In 2001 conducted a meta-review and found that there was in fact most likely a bidirectional relationship between job satisfaction and job performance, and that this relationship was mediated by particular factors about their work. And they also found that this relationship was stronger for more complex work. So consequently, we anticipated that we would also find this relationship for software developers and that this theory would hold, but we didn't know which factors would be important. And so we set out to consider this theory and run a study to understand developer satisfaction and productivity, and also to understand which factors impacted both satisfaction and productivity, as well as understand which challenges may play a role in their satisfaction with their factors and in terms with productivity and their overall work satisfaction. And so we conducted a study. It was 3 main phases. In the first stage, during the weeks that I spent at Microsoft, we conducted a lot of informal on-site interviews and also did an extensive literature review and identified 30 factors and 15 challenges. We then conducted a first survey with almost 600 engineers that responded, and this survey, through analysis of open-ended responses, revealed another 14 factors and 9 challenges. The supplementary materials for our paper describe where the factors and challenges came from. And then in a second survey with 465 developers that responded, we asked them about their satisfaction and how important these factors were to them, as well as to ask them about the impact of the 24 challenges on them. And from this survey, the second survey, we found no new factors and challenges. This just shows briefly what the survey looked like. We used a 5-point Likert scale questions for the importance and satisfaction factors questions that we asked them. And so just looking briefly at the challenges and the impact on the factors, what was interesting to us was that some of the challenges that they reported, these factors were, we found that they led to lower satisfaction with the factors that we show on the right-hand side when the respondents reported the presence of a challenge. And so, for example, when they indicated that manager was a challenge, this was associated with lower satisfaction across 16 different factors. The 44 factors that we had, we anticipated that some of them may be related, so we clustered them using a correlation cutoff of 0.5, and we ended up with 20 composite factors from doing this, so factors relating to engineering system, impact, the fact that their work is impactful, their work culture, their work environment, and that they are an important contributor. These are just some examples of the composite factors that came about. We then built some linear regression models. The first model was looking at overall job satisfaction, and this model shows which of the main composite factors appeared in this model. So doing impactful work, being an important contributor, and having a good work culture were the most important factors in this model. But we see also that their perceived productivity or their satisfaction with their productivity also appeared in this model as well. A second model for looking at their perceived productivity, the most important factors that came here was work autonomy, their engineering system appeared here, as well as doing impactful work. And again, we see that job satisfaction appeared as one of the variables in this model as well. So this showed us that these factors, many of the socio-technical factors, did impact their overall job satisfaction and perceived productivity, but in turn, that if you change one of these, that if you may be doing something to make them feel more satisfied, that you may in fact make them feel less productive. This particular instantiation of the theory here shows the instantiation for developers who spend less than 37% of their time coding. So we asked them roughly how they spend their time. Of course, like any other research, we do have limitations with our work, and we describe these in the paper, but just to mention that we spent quite a bit of time going back to the respondents and to managers at Microsoft, and our findings throughout resonated with the study subjects, and our research also aligns with other research by Murphy Hill, which was presented yesterday, and also by Graciotin on developer happiness. And so to conclude, this shows that there are many factors that may impact developer satisfaction and productivity. So for satisfaction, the most important ones are having appreciation, good work culture, good work-life balance, while for productivity, autonomy over their work, can complete their tasks, their engineering system, having good technical skills, or factors that impact their productivity, while impactful work and important contributors were factors that appeared for both satisfaction and productivity. And so just to wrap up, it's important to remember that anytime we may make a change to improve developer productivity, if it lowers their satisfaction, it may later on have a knock-on effect and actually impact their productivity as well. So one has to take care in making any changes to their work. So with that, I'll conclude, and I hope to hear some questions now or later on. And thank you, Alexander.
Thank you very much, Peggy. We have a couple of interesting questions. One of them is coming from Bogdan, who is wondering whether compensation is negatively associated with job satisfaction. And he suggests a very pragmatic solution: to pay people less.
Yes, that's a very good question. I mean, you know, we aren't able to explain that, but at the same time, we were kind of glad that we didn't see maybe in the other direction. And I suppose I don't think we should pay developers less. That is something that they said was one of the factors that was most important to them, but they were also quite satisfied with it. So yeah, we wondered about that one as well, but we're not going to pay the developers less, that's for sure. Thanks, Bogdan, for the question.
Good. And we have time for another short question asked anonymously. To what extent does the theory still apply during the COVID times? In what sense could the current pandemics have affected the factors related to productivity and satisfaction?
Yeah, so that's a really good question. So we are actually doing a follow-up study right now with developers working from home, and we are finding that many of the factors, obviously, that appeared before are still relevant, but we're finding new factors are more important now, such as work-life balance, and as many of us understand, trying to maintain a good work-life balance during work from home, and also dealing with more stress. So we're seeing some subtle changes in the importance of certain factors papers coming out. And also attention of, for some people working at home is very positive, being close to family, but for others that interrupts their work. And focus is also an interesting factor that's coming up a lot in this follow-on study. So,
Thank you very much, Peggy.
Thank you.
And let's move to the next talk. Our next speaker is Maleknaz Nayebi. She's going to talk to us about Eye of the Mind and its New Ideas and Emerging Results paper.
Hello, everybody. I hope that you can hear me well. I'm Maleknaz, and I am, you're hearing me from Canada today. I'm going to talk, as Alex said, I'm going to talk about the New Idea, NIR paper. So as X is going on, we are all following the events. My social network feed is more visual than ever. People are sharing a lot of their personal, attending conferences, family, and workspace photos. This is a screenshot of feeds from last night in my Twitter. And well, this whole notion of sharing images, specifically if you're like me, a fan of Instagram, the researchers on communication and social networks, they all believe that the emergence, the occurrence of the visual social networks like Instagram and Pinterest and Snapchat changed our behavior in general purpose networks like Twitter and Facebook as well. And so I was so curious to see how these whole types of images that we are sharing also impact the way that the developers are communicating in software teams, how this trend of sharing visual content impact developers, and do they share more of multimedia content in software teams? If so, what does this mean for all the tools and techniques we have for task automation, for increasing productivity, for decision support in software teams? Because as you know, they are all based on heavy analysis of text and applying NLP to software-related text these days. So I examined 3 hypotheses to see how this trend is going on, and then to unfold the future. First, I examined if there is an increasing trend of sharing images similar to what's happening in general purpose social networks. And if so, if these images are complementary to text, or these are just some memes or GIFs for fun. And then the last that I observed was that if these images actually facilitate some type of communication between developers, like is they're purposeful and informative. So for the first one, we looked into the posts in Stack Overflow and Bugzilla, the two very, the very common sources that we all look into the software engineering community. And then for the last 2, we looked in, we performed a survey with developers. And when we are observing and examining if there is an increasing trend or not, we looked into a stack of like 1 million threads of posts about Python, Java, or JavaScript in a Stack Overflow. That included a total of 3 million posts. And we examined how many of them has images and what does these images mean. And as you see, there was an ever increasing trend here in the number of posts with an image. And there is an increase in the proportion of questions with an image. So more than ever, people are sharing images when they are posting on Stack Overflow a question. When looking into Bugzilla, the trend was exactly the same thing. It was increasing. We looked into 4 main projects of Mozilla. And one interesting thing that we observed was that the number of issues with images have been doubled in 2018, when the number of posts in general there was only 20% increased. So when we looked into this around 22,000 images in the Stack Overflow and Bugzilla, and we surveyed 168 software developers to see if actually these images help them to understand images to text better or not, the issues or the bug reports or the questions. And as you see, in 88% of the cases, that actually helped them to understand the content of the text better. And 86%, 87% of the developers said that it is unlikely or very unlikely to understand the text without looking into these images. And when we ask them why actually these images are shared or what they think about sharing images, they say mostly it's to facilitate comprehension, the text understanding, to communicate faster. So they just threw a screenshot there to make sure that they are communicating all the details needed, and they can be more precise about that. Looking into the nature of these images, we ask them to categorize what are the shared images, and as you see, there are 10 main categories: inputs, outputs, performance, algorithms and concepts, like just describing some knowledge, the code itself, the runtime errors, dialog boxes, and so on and so forth. So 10 general categories. But what does that mean for future? So analyzing software-related text, as we are doing right now in the community, is not enough. And with more visual content being shared by developers, reasoning based on text will be more and more biased, so that on understanding of the text, analyzing text is not enough. We need to hire image processing tools and techniques here. For instance, this is a Stack Overflow post, and we applied the machine learning object detection and text detection tools on it, and it has a very good accuracy, as you can imagine, because everything is typed, not handwritten, for example, and the objects are all on the grid. So okay, and then the tools and techniques are working pretty well. And then so just looking into text is not enough anymore. Visual artifacts more than ever are shared, so our recommendations and decision support tools can no more just rely on textual content either. We just or just navigation, showing some navigation through the code is not enough. We need to assist the developers with the more visual content to basically cope with the new ways of communication. So we should become ready to not only understand but also develop visual recommendations. So here, for example, with the machine, we generated number 3 here. We generated an image by a machine to address a problem reported on Bugzilla. And if you compare it with what have been generated by humans, by developers themselves, you see it is pretty much comparable. So my question to you is that, are you ready? Are we ready to apply these techniques and move on from NLP techniques? So by that, I wrap up the discussion, and I take any questions if you have time.
Thank you very much, Meleknaz. We have time for a very short question, actually for a very short answer. The question is whether you look at the content of the images and whether they're mostly screenshots of the code or bug messages or diagrams.
Looking into frequencies, very often it's error messages.
Thank you very, very much. And let's continue this discussion after the
Thank you.
In different boxes. So our next speaker is Claire Ingram, who is going to talk about local meetups as a way to share software engineering knowledge. Claire, the stage is yours.
Let me just share my screen.
Yes, please.
Great, thank you. So my name is Claire Ingram, and I'm based at the University of York in the UK, along with my co-author Anders Strachan. And I'm here to talk about what we know about how software practitioners are using informal local meetings to share software engineering knowledge. So I think most of us probably are aware that thousands in the last 10 years or so, there's been a huge growth in the number of local communities and clubs in cities all around the world that are facilitated by platforms like Meetup and Eventbrite and Facebook that allow strangers with shared interests to come together and form communities. And a significant number of those local communities actually are created by and for technology professionals who now regularly meet after work in their local cities to discuss software development topics in their spare time. Despite the size of that community, though, and how rapidly it's grown, very little is known about why people participate in them, what they take away from these communities, and the potential for local groups and meetings to influence software development in practice. So we set out to find out basic information about all of these kind of questions. We did have a number of research questions in the paper. I don't have time to cover all of them today in this short talk, but let me cover a couple of them to give you a flavour for what we've uncovered. The first question I'd like to cover today is what motivates software professionals to participate in these technology meetups. And we think this is an interesting question because if people are voluntarily giving up their spare time to go along to meetings after work, that implies that the meetings meet some sort of need, and we're interested in understanding what those needs are that practitioners have. And secondly, we set ourselves a question of trying to find out whether these informal local meetings are allowing software professionals to access some kind of resources or knowledge or contacts that they find difficult to get through other means. And we find that an interesting question because, of course, like all of us, practitioners have access to huge varieties of information online in different forms, like Stack Exchange and Twitter for getting technical answers to technical problems, as well as tutorials and webinars for learning. So if they're voluntarily going along to local meetings, which are city-based, place-based, and face-to-face, does that mean that there's something about being able to talk to other people in your local area that's special? That's an interesting question because we think it's relevant to regional development. You might find that there are some cities that have a long track record of being technology focused, who have maybe a rich community of people and experienced practitioners who are ready, able to share with their peers. You might find other cities that are much more emerging with growing technology clusters who maybe have a much smaller community. So that's something that's quite interesting to for purposes of regional development. We answered the questions with a research design which is fully described in the paper. We selected some different cities in the UK which all have very different economic characteristics, but all of which are recognized as technology clusters. And we collected information from group leaders who've created and run meetup groups by interview, and we collected separately information from people who go along to meetings through surveys, and we compared the two results as a triangulation effort. The full details of the research design are in the paper and the sampling rationale that we had. Let me talk a little bit then about the first of those research questions, which is what motivates people to participate in meetups. We broke that into two. We're interested in understanding what motivates someone who starts a meetup group and runs it, which is quite a big undertaking. And we're also interested in what motivates people to go along as a participant after work. I'm only going to cover one of those in this short talk, which is to understand a bit more about what motivates group leaders. Group leaders in interviews told us about lots of different motivations that they had, understandably, but the two major ones which came out of interviews, which most interviewees mentioned in some way, were first of all an interest in learning and their own career development and continued professional development, and all of them had reasons why they saw Meetup as particularly strong for that. And secondly, a large proportion also were very interested in creating opportunities to meet people or to build a local network. And they gave us a large number of different reasons why they thought it was important to be able to build a local network, some of which were about building a local reputation for themselves, and some of them were about building up a community for themselves and for others to benefit from. Let me turn to the second question I mentioned about whether meetups provide something which is additional to online resources like webinars or technical resources like Stack Exchange. We asked quite open-ended questions here to our interviewees, asking them what they thought was the major benefit of going along to a meetup to learn or take away things from a meetup. And they gave us quite a lot of answers. I'm going to touch on just a couple here because we're a little bit short of time and there's a lot more detail in the paper. But here's a couple that I found quite interesting. And the first is that several people mentioned to us that the meetups were really helpful as a source of reassurance. And many of the participants going along to meetups were quite experienced practitioners. More than half of people who responded to our surveys who go along to meetups regularly had more than 10 years experience in technology fields. But some of them are working perhaps in quite isolated areas, or perhaps they're the only specialist in the firm, or they might work in non-digital native firms where the technical team is small. And being able to access a community which is above all friendly but also full of other experienced peers gave them a forum for reassuring themselves that the challenges they saw were common to everybody, and that the directions they were going in and the solutions they were proposing in their own work were the right ones. So a source of reassurance was important. And a second concept which came out of our interviews, which we found very interesting, was that many of our interviewees mentioned the importance of hearing stories. And by that, they mean that they appreciated being able to hear other experienced practitioners talk about projects they'd completed, which is quite a common topic for a meetup. And in doing so, they usually describe not only the technical solution and what the architecture looked like, but usually also a little bit about the application domain they come from and things that are specific to that, maybe the team dynamics, maybe changes that they had to make. And that's a way of communicating some experience-based knowledge that they've acquired. We do know from other fields like the knowledge management community that software engineering is heavily underpinned by what's called tacit knowledge. That is not knowledge which is secret, but knowledge which is based on experience, which is quite closely tied to very specific applications and contexts which we take for granted and which is very difficult to share. And that's intuitively something that sounds right to a software engineer. We get to be a good software engineer through experience of developing software. We learn what works and what doesn't. That's quite closely tied to our specific experiences. And it's very difficult to make someone else learn that from a book. They have to go through the same experience themselves. And so telling stories which are very heavily detailed with lots of contextual information is one way of going some way to sharing that kind of tacit and experience-based knowledge, which is very important for software engineering in particular. Let me make a few concluding remarks. We did gather some other data. We found that there is some evidence that many people who go along to meetups do find that they provide useful and relevant information. Very many people who responded gave us examples of things they've taken away and put into their own practice. And also, as I mentioned earlier, we found that out of everyone who responded, most of them were very experienced practitioners, although just under half have less than 10 years experience as well. So they are very welcoming and open communities. And we did find some evidence that suggests to us that these meetups can be very useful forums for sharing tacit and experience-based knowledge, which we think is important for software engineering. Some of the types of examples people gave us where they've learned new knowledge were really the kind of challenges which are quite difficult to master, things like elaborating requirements better to reduce rework later on, and improving the way we collect information from business users so that we get better quality requirements to start with, those types of things. So we think this meetups are particularly a very useful resource for SMEs or people working in very small technical teams where there isn't a large community of other experienced peers to bounce ideas off of. And we think also it's worth looking into this from a position of regional developments, because the regional knowledge pool, which these meetups do tend to tap into and make available, may vary across different regions depending on the number of people participating in different regions or available to participate. And I think I'm probably just about out of time or running over, so I will welcome any questions, or if you read the paper and have any interest in this topic, I would be delighted to hear from you. And thank you very much for your time.
Thank you very much for the very interesting talk, Claire. We have a couple of questions in Slido. So Max Dipente is asking about your results and whether how they would look given the current pandemics and lockdown. Would it be possible to replicate the study?
It's a really interesting question, and that's something I'm looking at the moment. It would be nice to be able to, again, ask the same sorts of questions and find if there's different answers now that the possibility of meeting face-to-face has been gone for quite some months for most people. So that is something we're actively looking into at the moment.
Another question is, group of questions is related to the difference between online communication and offline communication. So whether you also looked at online meetings and whether there are differences between those meetings and the offline meetings in terms of reassurance and so on.
That's exactly what we'd like to look at now. I think that that's something that's really only been readily available recently, now that most of us have got a lot of experience of a lot of online meetings that perhaps we hadn't had quite so much of until this year. So I think that's a really rich question, and it is worth knowing, I think, whether it does make a big difference, whether you can try and replicate the kind of open and welcoming face-to-face informal community that you get in a person-based meetup over virtual means. And I think most of us have an interest in trying to learn whether that can be replicated, and if so, how.
So thank you very much, Claire.
Thank you.
Our next speaker is Franz Zieris, who is going to talk to us about pair programming. Franz, the stage is yours.
So, hello everyone, welcome to my presentation on the session dynamics of pair programming. My name is Franz Zieris and this is joint work with Lutz Brechelt. If you talk to software developers in industry and ask them, why do you pair program? Typical reasons are that they want to achieve better designs or they want to avoid defects. Others may want to learn some new technology from a colleague, or they need to address some legacy part of the software and need to understand it better. In all these cases, knowledge and knowledge transfer plays a huge role. In our research, we want to understand how pair programming in industry actually works like. And in particular, we want to understand how pair programmers deal with what they know and what they don't know during a pair programming session. Ultimately, we want to advise practitioners on how to pair program more effectively. So to this end, we perform qualitative research. We follow the grounded theory approach, and we analyze recorded pair programming sessions of industrial software developers who work on their everyday tasks. These recordings consist of a screencast, webcam, and audio of the developers. Through theoretical sampling, we collected a number of sessions in different companies, and for this particular analysis, we selected 26 pair programming sessions from different application domains, technology stacks, pair constellations, and so on. I'm now going to walk you through our analysis approach and what we learned along the way. So when we first tried to make sense of our data of our 26 pair programming sessions and 26 pairs, each session seemed pretty much unique. So we started with a bottom-up approach of analyzing the pair programmers' dialogue. So we looked at the questions that they asked, the explanations they provide, to get an understanding of what's going on in their sessions, what they need to know, and what they learn along the way. And the first group that stood out to us were pairs where one pair member had already worked on the task. So this pair member has a more up-to-date mental model of the current implementation of the software system, knows about class hierarchies and so on. And this is task-relevant knowledge which her partner lacks. And we call this difference in system understanding between two developers the primary gap. And there are several approaches how pairs can deal with that primary gap. And the most common one is that the so-called task expert explains to a partner what she already did. But let's look at the other group, where there is no task expert, so there is no developer who has an advantage in system understanding, so there is no primary gap. But there are different starting conditions for these pairs. For some pairs, both developers basically know everything there is to know about the system. So possibly they have recently worked in that code area and know it quite well. Or a second group where developers have a basic understanding of the software architecture and the modules, but they still need to piece a few things together. And then there's a third group down below who basically sees the source code for the first time. And in all these cases, the shared lack of system understanding, where both developers need more system understanding, is what we call the secondary gap. And to close the secondary gap, the pairs may need to read source code, play around with the application, or simply do printf debugging. And actually, most of our pairs were able to close their secondary gap by doing just this. So they reached a high system understanding through the course of their session, but not all pairs did. So we wanted to find out what prevented these pairs from reaching a good system understanding. Take this pair, for example. They were supposed to implement a test case, and they spent hours trying to find out how to access the state of the application. But they were not able to build up that system understanding because there was a different kind of knowledge that was also lacking. These two developers were somewhat experienced, but they were not familiar with the particular dialect of the programming language they were dealing with, and also the application framework and the test framework was unfamiliar to them. So this is a different type of knowledge, which we call G knowledge, which is general software development knowledge that is task relevant. And this particular pair lacked both system understanding as knowledge and G knowledge, and they eventually gave up on their task. So with these two types of knowledge, S knowledge and G knowledge, we wondered what the relationship between these knowledge types might be. And it turns out that system understanding is relevant for all pairs. So all pairs need to get at least good enough understanding of the system in order to get productive. And the G knowledge is some kind of floating device which helps them reach a higher understanding. And if a lot of that G knowledge is lacking, just like in the pair we just saw, that might be quite difficult to acquire the necessary system understanding. So if you don't know the test framework at all, it might be hard to understand the existing test cases. If, on the other hand, there's only a small gap in G knowledge, for instance, you don't know every last feature of the test suite, it's not as problematic. But what about a pair with a relative difference in G knowledge? For instance, there are pairs where one pair member knows more about design patterns, for instance. Well, this type of gap was never problematic. It was only an opportunity for the pairs we studied. So some pairs seized that opportunity and explained, for instance, the template method pattern to their partner, but not all pairs did so. So if we zoom out again and consider all our 26 pair programming sessions and position each developer according to what she knows regarding the system, the S dimension, and regarding how much she knows about software development in general, the G dimension, we get roughly this picture. Note that these two dimensions are qualitative, so there's no quantitative metric involved here. And when we have this picture, we get to see a very nice overall session dynamic that is common to all our sessions. What pairs first do is they address the primary gap. So if there's one software developer who knows more about the system, this primary gap is addressed first in a pair programming session. Then, when both developers have a similar understanding of the system, then they go about addressing the secondary gap. So both developers acquire the remaining system understanding that is necessary for working on their task. And only then, with both primary and secondary gap closed, some of the pairs seize the G opportunity and transfer software development knowledge that goes beyond the particular software development system. So to summarize, a lack of system understanding or a difference in system understanding between the pairs has far more impact on the session dynamic than any difference in general programming experience. So what we observed is that it's not important how many years of experience a developer has, but how much applicable experience they have for their particular task. So what matters is task-relevant knowledge, not overall knowledge. And if the same developers were working on different tasks, there would be different knowledge needs and a different session dynamic. In this context, I would like to point out a particular constellation, which we call the complementary gaps constellation, where one pair member has a more system understanding, higher S knowledge, and the partner has more general software development experience, higher G knowledge. This constellation is nice because both partners can teach and learn something. You can find more about this constellation and all the others, as well as many examples in our paper. Thank you very much for your attention.
Thank you very much for your presentation, Franz. We have some time for questions, and the first couple of questions are already in Slido. Ita Richardson asks whether the attitude makes a difference, and by attitude she means things like whether one person is a natural leader.
There are different ways, for instance, how pairs go about closing their primary gap. So if there is a difference in system understanding, some pair members simply don't like to get an explanation. They like to look in the source code directly. And in this case, pair programming is not very helpful because the partner cannot do much about this. So there's one developer reading and the other just looking and waiting until that newly joined partner has the same level of system understanding. So there are some personal preferences involved, but it's usually not a problem, at least in our data.
Thank you very much. Another question from Ita is related to gender. Did you observe any differences between same gender and mixed gender pairs?
There were differences, but I would not pin them down to the gender of the developers. So yes and no. And I'm happy to go into details after the presentation.
Okay, this makes me very curious. And the last question is probably about implications. What kind of implications does your work have for developing tools to support pair programming? How can we support pairs in being more effective?
So not so much in technical tools, but this kind of chart I showed, pairs could think about before starting to work, where are we on this chart? Do we have a beneficial constellation like this complementary gaps, or can we achieve one? Or do we have only a primary gap where only one developer gets to explain things? So thinking about the particular knowledge gaps regarding these two dimensions might be helpful before starting a pair programming session. So it's a soft tool, not a hardware, not a software tool.
Thank you very much, Franz. And our next speaker is Jiawei Wang from Monash University, who is going to talk to us about analyzing Jupyter notebooks. And it's also a near talk. Jiawei, please go ahead.
Thank you, Alex. Hi, everyone. I'm Jiawei Wang from Monash University. I'm going to present our work, Better Code, Better Sharing, on the need of analyzing Jupyter Notebooks. Jupyter Notebook is a kind of a web application that allows users to create and share documents that contain live code, results, visualizations, and explanatory text, or even equations. So as you can see from this example, according to a price study, there is increasing popularity of Jupyter Notebooks. As of the September of 2018, there had been more than 2.5 million Jupyter Notebook repositories on GitHub, which is 10 times more than that in 2015. However, to the best of our knowledge, our community has not proposed very promising approaches to automatically analyzing the Jupyter Notebooks. So to this end, we conduct a preliminary study of large set of Jupyter Notebooks, checking if the code presented in these notebooks is of good quality. We propose the following two research questions to understand. The first one is, to what extent does the code in Jupyter Notebooks respect recommended Python programming conventions? In other words, how does the code in these notebooks respect the PEP8, the official style guide for Python code? And the second question is, how does the quality of actual code in Jupyter Notebooks compare with that independent Python code? We check in this research question if the unused variables in these notebooks have been introduced. And additionally, we also look at if notebooks contain the deprecated functions from Python libraries. As a representative example, we investigate the use of deprecated functions from sklearn, which is a very, very popular machine learning library for Python. To answer these two research questions, we turn to a set of notable Jupyter notebooks. We selected the projects from a gallery of interesting notebooks that is maintained by the official Jupyter team. So we choose Python-based notebooks only, and automatically collected 1,982 notebooks. And the topics from these notebooks can be from mathematics, signal processing, and natural language processes. So each of the projects is composed in such a structure, as you can see from this diagram, where you can find the Jupyter notebooks and independent Python code. Independent Python scripts contain some code that also can be used for these Jupyter notebooks in the same repository. The result for the research question one, we narrowed our results by the error ratio, which is the value that the number of error messages produced by PEP8 checker divided by the number of lines of code. So as you can see from the table, the error ratio for notebooks and independent Python scripts are 36% and 13% respectively. In other words, this evidence shows that code in these notebooks are not well aligned with the recommended coding practices. And as for the research question two, how does the quality of this actual code compare with the independent Python code? We experimentally found 118 and 66 repositories, which out of 147 whose notebooks and independent Python scripts contain unused variables. This value also shows that Jupyter notebooks have introduced much more unused variables than that of independent Python scripts. When it comes to the use of deprecated functions, among 215 notebooks and 66 independent Python scripts where sklearn is used, 76 and 15 of them have somehow leveraged deprecated APIs. So in other words, we can conclude that Jupyter users needed to pay more attention to the quality of their code. So based on these results, we propose the following directions for future studies: enforcing good coding styles, improving code quality and reliability, applying best practices for software quality, and ensuring a good balance between text and code. And finally, I would like to also share another our work, which is from PosterTrack on Jupyter Notebooks, restoring the reproducibility of Jupyter Notebooks. As we know that reproducibility has always been a focus of our research community, and given that notebooks are widely being used by data scientists or other researchers to present their results of their research outcomes, we believe that it will be very important to make them reproducible. And now I would like to take questions from you.
Thank you very much for your presentation, Jiawei. We have one question in Slido. It's coming from Neil Ernst, and he asks whether there is a good way to control for code that will be in production as opposed to code that is in exploratory and is going to be used only once.
Well, it's actually a very good question. Although I can't tell a conclusion, but given these notebooks that as our research subject, they are from a very high quality, so-called very high quality notebooks, we believe that this code should be given enough maintenance. So because we choose notebooks from a gallery of interesting notebooks that are officially listed by the Jupyter team. But as for random choosing notebooks from GitHub, I don't think it's necessary to make them always high quality. This is my personal idea.
Thank you very much for your presentation again. Unfortunately, we need to move to the next talk, but please come to the Slack channel room back here and continue the discussion there. Our next speaker is Naveen Raman from the University of Maryland, College Park, who is going to talk to us about stress, burnout, and toxicity. Naveen, the stage is yours.
Hi, I'm Naveen, and I'll be talking about stress and burnout in open source towards mitigating unhealthy interactions. So recently, contributors in open source have been reporting examples of burnout and stress and things like that. And this is caused by a lot of factors, one of which is the overwhelming number of GitHub notifications. As one developer put it, GitHub notifications are a constant stream of negativity, and reading through these can be mentally and emotionally exhausting, which is a big problem. And at a recent poll taken at Scholar Days 2019, the audience was asked, do you ever feel overwhelmed with the amount of feature requests or bug reports in your open source projects? 15% of the respondents reported often, while 32% reported sometimes, hinting that a decent portion of developers do feel burdened by the amount of pressure put on by open source users. And what adds on to this is the language that certain open source users take towards the developers. There's essentially a feeling of entitlement from these users towards the developers. As an example, they demand certain feature changes, even though these developers are largely unpaid volunteers. And they act rudely towards these developers, which adds to the stress of developers and makes it hard for them to contribute. And this is a big issue because this puts open source at a risk. Open source is a fundamental part of our modern infrastructure, and as the Road and Bridges paper put it, open source is a part of our everyday lives. It's on our phones, it's everywhere, and many of the apps rely on open source. And so when there's issues with open source, we can see things like the Heartbleed issue and the Equifax hack, which was largely caused by some type of open source issue. And another issue is that if there's lots of stress and burnout put on these open source developers, it leads to less diverse people using open source developers, which leads to lower quality code. And so the question is, how can we understand and mitigate this stress and burnout that occurs among open source developers? This naturally leads to a couple of questions that we want to answer, which is how prevalent is stress and burnout among open source contributors, and what are the causes in open source of this stress and burnout? How does this compare between work environments? And also, who's the most at risk from stress and burnout in open source? What demographics, what groups? And what interventions are effective? How can we prevent stress and burnout. So what we do is a preliminary study where we take GitHub information on issues and comments, and we use an out-of-the-box classifier using as many components as possible because we don't have much data, where we label the data based on whether the interactions are toxic or non-toxic, and we try to detect and analyze toxicity in these GitHub comments which cause this burnout. So we use a variety of different features to see what causes burnout. As examples, we use like Google Perspective Score and other NLP-related features. And there's more details about this in our actual paper. And so one of the issues that we run into is that certain words have different connotations or different meanings in software engineering versus in regular life. So for example, the word abort in software engineering refers to like aborting a commit or things like that. But whereas in regular life, it holds a much more negative connotation. And so this really threw our classifier off. And it was a really like tricky problem. And we have details on how we work around this in our paper. And so what we did was we used our classifier to analyze how toxicity differs between different communities. For example, we compared how corporate and non-corporate issues, the rate of toxicity between corporate and non-corporate issues, and we found that non-corporate issues had a significantly higher rate of toxicity. Similarly, we looked at issues by the language. So depending on like what language the repository was in, we looked at the rate of toxic issues and found that there was a difference between different language communities in terms of how much toxicity there is. Finally, we looked at toxicity over time on GitHub, and we found that over time, toxicity is generally decreasing, which is a good trend in that GitHub, in that for some reason, toxicity is getting better over time. This is only a preliminary study, and we've only shown some correlations between different features. And the question is, why do these correlations occur? And this also leads to the question of what can we do about stress and burnout in open source? And also the question of what should we do about stress and burnout in open source to try and prevent this in the future? Any questions?
Thank you very much for your presentation. Naveen, there are a couple of questions in the chat. So is there a data set available?
Yeah, we have a GitHub repo which says, so our data set is based off of the GHTorrent data set, which has a database of all the GitHub issues and comments. And then on our GitHub page, we have labels for some of these issues and comments.
Good. And another very, very brief question. Is there a corporate community where the users can pay, for instance, for premium support? Like, what is exactly this corporate community?
So for corporate community, what we looked into was projects that were primarily like supported by some type of corporate entity. So for example, we looked at repositories such as the ones developed by either Facebook or Google. And we compared those to the repositories that were primarily not associated with any company and were just open source.
Okay, thank you very, very much, Nav. And our last speaker is essentially a pre-recorded presentation. It's a journal first talk on good work habits in software development and reflective goal setting.
Hi, my name is Andre Meyer and I'm a postdoc at the University of Zurich. In this talk, I'm going to tell you how reflective goal setting can help software developers to increase their productivity and well-being. This was a joint collaboration with Gil Murphy from UBC, Tom Zimmerman from Microsoft Research, and Thomas Fritz from the University of Zurich. Software developers are motivated to develop better habits that help them to improve the productivity and well-being at work. However, in reality, they have often difficulties to identify concrete goals and actionable strategies to do so. It is therefore desirable to gain a better understanding of what good work habits and behaviors really are, so we can help them later with the identification of self-improvement opportunities and help them to maintain good habits at work or build better ones. In several areas of life, such as the physical activity and health domain, self-reflection as well as goal setting has been shown to be very successful at increasing people's awareness about problematic behaviors, and that it helps them and motivates them to define self-improvement goals and foster goal achievement in the end. In the workplace, however, and in particular software engineering, only very, very little is known about positive and productive work habits and the individual strategies that help developers to improve themselves. This is why our goal was to investigate what developers' existing goals are that help them improving themselves and maintaining good work habits, and also what strategies they pursue to reach them. We further aimed to examine whether encouraging developers to self-reflect continuously on work results in any meaningful insights about work or leads to any work habit goals. To investigate these research questions, we combined self-reflection and goal setting to design a reflective goal-setting study, which was inspired by the personal software process and diary studies in other areas of research. In our study, we asked 52 developers to reflect about work on a daily basis for several weeks. Every morning, they would reflect on what they had planned to work on for that day, and in the evening, they would reflect on the progress they made on those tasks, what went well and what could be improved, and we asked them to set goals for the next day to keep having a good day the next day or improve it even further using the SMART goals approach. This has resulted in a broad set of qualitative data with more than 600 self-reflections from about 11.5 work days per participant on average. We then performed a thematic analysis, which resulted in a rich set of 15 work habit goals and 27 actionable strategies to improve and maintain good work habits. These included more obvious goals, such as planning one's workday in advance, but also more specific ones to software engineering, such as better handling unplanned bugs or doing more code reviews. From the goals, we asked participants to develop and experiment with strategies to reach them. Every day, they would slightly adapt their previous workday goal or strategy, and in the end of the study, every participant had a set of 2 to 4 highly personal and relevant goals. For example, many participants wanted to become better at planning workdays in advance. So participants started to block time in their calendar, for example, that would help them to work more focused, and they would create subtasks to become better at estimating the workload. Developers who wanted to become a better colleague often learned that they should not only take the important complex tasks for themselves, but also share them with their team and delegate them, and also set enough time aside to help or mentor teammates. To better handle unplanned and urgent bugs, many noticed that they don't always need to drop everything right at the time when a new urgent bug comes in and jump to that unplanned task, but that often it's feasible to finish the current one first and avoid a costly context switch. In the paper, you can find detailed explanations and insights into those 50 goals and 27 strategies. While we run the Reflecting Goal Setting study to gain insights on goals that developers set for themselves, what was really surprising to us was that we learned that the method itself was actually really valuable for participants. After a few days of getting used to reflecting about work, the majority of participants reported that these self-reflections about work they had to do daily really allowed them to gain actionable insights and come up with productive self-improvement strategies. The main reason was that while most wanted to improve themselves, they often had very few concrete and actionable ideas on how to improve their work habits. This is because most developers rarely reflect continuously and purposely about their work. When they were enforced and encouraged to reflect continuously and purposefully every single day, the self-reflection process allowed them to experiment with and identify concrete self-improvement opportunities. As a result, 84% of all participants stated that the process increased their awareness. So they learned a lot about their own work habits, the progress, their achievements. And as an example, one participant mentioned that she can better decide whether she wants to accept an interruption from a coworker or if she asks the coworker to come later. 81% mentioned that they could successfully identify concrete goals. 83% identified actionable strategies to reach those goals. So overall, as a result, 80% of all participants reported that they had productive behavior changes, which helped them to increase well-being and productivity. Now that we have a list of 15 goals that are relevant to developers and 27 actionable strategies, we can think about how we can use them to help developers. Generally, more than 90% of all participants mentioned that they would be interested in including some kind of regular reflection in their work lives, especially since they are already reflecting on other parts of their work, such as code quality, progress, performance with their team. However, the positive effects might not last forever, since it takes a lot of effort to self-reflect on a daily basis. So it could be valuable to support goal identification and goal monitoring using some tools. One obvious idea is to include the goals and strategies that we identified as suggestions. Or we could also include automated self-monitoring approaches, which would, for example, try to visualize how developers are progressing and towards their goals. Or we could integrate better into existing workflows. For this, for example, suggested that we could include the whole approach, the whole self-reflection approach, as a bot into Slack or Microsoft Teams. Finally, this was more controversial. A couple of participants mentioned that they would benefit or it would increase their motivation when they would have reminders to actually work on their goals, or even if there was a gamification system in place. Paper experts of their developers' goals and strategies to improve or maintain good habits at work. While initially most developers were quite skeptical to react on a daily basis over multiple weeks, the majority of participants was surprisingly happy with it and found a lot of value in doing so. This shows that continuous and active reflective goal setting allows developers to not only identify work habits, but also to reach them. If you want to know more, please have a look at our paper, and I want to thank you for your attention.
Hi.
So this is a pre-recorded presentation, so unfortunately we cannot ask the questions to our presenter. But I know that some other co-authors, such as Tom Zimmerman, are attending the conference, and they can answer your questions either on Slack or in the chat box corresponding to this paper. This concludes our session on Human Aspects 1. And I would like to invite you to join the following up session on Human Aspects 2 in the very same room back here, chaired by Giuseppe Scaniello. You can also talk to the speakers either in Slack or in lobby during the video chats in the third session hour. Goodbye, and thank you very much for your attention.
Hello. Hello to everybody.
Can I share my screen now?
Yeah. Hello to everybody. This is the A10 session, Human Aspect 2. We have 5 papers. 4 papers are journal first, and last but not least is a technical paper. So let's start with the first presenter, that is Meng Yang. He will present the paper titled Characterizing and Identifying Reverted Commits. Thank you, Yemeng, for joining us.
Okay, thank you for your introduction. But I cannot. It seems that my sharing is abandoned, so I cannot share my screen. Okay, it's okay. Huh? Sorry for delay. Hello, everyone. My name is Meng Yan, come from Chongqing University. Today, I'm very glad to share our IMSI paper, Characterizing and Identifying Reverted Commits. What if you discover a problematic commit? A problematic commit may be a commit introducing a defect, introducing technical debt, or implementing an unnecessary feature. Usually, we will consider to fix it. Another solution, another coarse-grained solution is to revert it. So reverting is a coarse-grained approach for recovering from a problematic commit. Here is an example of the reverting commit and the reverted commit from HBase project. The left side commit, we call it as a reverting commit, which is submitted in September 2017. The right side commit, we call it as a reverted commit. It was submitted in April 2016. From the commit log of the reverting commit, we can find that why the reverting commit reverts the commit, and we can identify the commit ID of the reverted commit from the commit log. So what's the impact of a reverting a commit? Suppose the commit 1 is the reverted commit. It modified the file A to file A plus. The commit 2 is the reverting commit. This commit modified the file A plus to file A. So the commit 1 may linger for a long time during the life cycle of the software development. So after reverting the commit 1, we may think, should I update other related code? If yes, so what is the context of the commit 1? We need to record the context of the commit 1 to update the other related code. So the reverting may increase the difficulty of the software maintenance and impeding the development progress. So our motivation is that what are the characteristics of the reverted commits, and can we identify reverted commit just in time? So addressing this question, we can bring some benefits, such as we can help to understand the reverted commits, and we can inform developers just in time about which commit will likely to be reverted, and we can do some early detection and fix of the problematic commit. So to address this question, we propose an automatic approach. In this approach, first we will extract the historical changes from the Git, and we will label it as reverted or not from from the diff of the commit and the commit log of the commit. Then we will extract commit level features. In this paper, we extract 27 features to categorize each commit. Then we will use a random forest model to build a classification model. This is our model building phase. In our model application phase, when a new commit is coming, we will identify it as reverted or not. We conducted an empirical study to evaluate our approach by designing 3 research questions. In our RK1, we investigate the performance of our approach and compare it with 4 baselines. The result indicates that we can improve 4 baselines by a substantial margin with a statistical significance and large effect size. In RK2, we investigate the impact of the different dimensions on the performance, and we found that the developer is the most discriminative dimension. However, using all dimensions of features is better. In our RK3, we investigated the feature importance. As a result, we found that the lines of added and deleted code and the experiments of the submitter are the most discriminative features for identifying reverted commits. Finally, we provide some implications for both practitioners and researchers. For practitioners, the analysis and handling of the reverted commit cannot be ignored, because we found that in our dataset, about 2.5% of the commits are reverted, and the reverted commit can linger for as long as 800 days. And the developers should pay more attention to the commits made by these experienced developers. In terms of researchers,
you have 1 minute more.
Okay. The labeling method for reverted commits should be reverted. Previously, they label the reverted commit by only checking the commit log. In this paper, we propose to check the commit log and at the same time check the diff of a commit. And the further research for enhancing the performance can pay more attention on the feature of the developer and change dimensions. In summary, in this paper, we highlighted the problem of the change level reverted commit identification. And we propose an automatic approach to address this problem. And we conduct an empirical study to evaluate our approach. And finally, we provide some implications for both practitioners and researchers. So thank you for your attention.
Thank you very much, Meng.
Thank you.
We have 2 questions. If you were able to shortly answer this question, we could answer to both that. Okay. So the first one is, can you briefly explain what features are you using?
So what features?
Yeah.
Okay, sure. Such as we use 3-dimensional feature from change, developer, and message dimensions. In change dimension, we extract some size features, diffusion feature, and significance features from the change code. And in developer dimension, we capture the features of the developer from such as how many developers touched this changed files, and the experience of the submitters and the ownership of the changed files. From the message, we extract some features from the commit log by checking some keywords.
Okay. The second one is, to which degree is your approach applicable to cross-project versus project internal reverted commit detection?
You mean a cross-project identification model? In our paper, we investigate this problem in our discussion. The results indicate that the cross-project model cannot compare to the within-project analysis. So you can check the details from our image paper.
Okay, thank you. There are also another question, but I think that further question can be asked later using the right channel. Okay, the second speaker of this session is Haoxiang Zhang. He will present his paper, that is a journal first paper. The title of that paper is an empirical study of obsolete answers on Stack Overflow. Thank you very much. Okay, I'm sorry. I forgot that my microphone was muted. So the second speaker is Haoxiang Zhang, and the paper is an empirical study of obsolete answers on Stack Overflow.
Hello, can you hear me?
Yes, we can hear you.
Okay. Hello, everyone. In this journal first presentation, I'm going to talk about our IEEE transactions on software engineering paper. I'm the presenter, Haoxiang Zhang. And in this work, we conduct an empirical study of the obsolete answers on Stack Overflow. Stack Overflow is a question answering website for programming, and its crowdsourced knowledge has increased rapidly over the years. For example, from 2013 to 2019, the number of answers has more than tripled. It has become the primary site for programming knowledge. As we know that the software nowadays are rapidly evolving. For example, in Android and Angular, there's many versions over the years. So every year, Stack Overflow conducted a developer survey, and the one question was what developers are concerned about. And as I highlighted here, that the outdated information is one of the concerns. And here are the two comments. They either pointed out some information is out of date or something is obsolete. So all that motivates us to conduct a mining project to understand how the knowledge become obsolete on Stack Overflow. And we use keyword searching to find 52,000 answer thread that become obsolete. And we randomly sampled 669 for manual study. So here I'm going to present some of our key findings. And for more details, you can refer to our paper. First, we found that more than half of these obsolete answers were already obsolete when they were first posted. So they can be observed within 1 day. And then we suggest that automatic tools are needed to maintain such answers. And on top of that, we analyze who observed these obsolete answers, and we found that the majority of them are observed not by the original answerers, but they can be observed by askers, other answerers, commenters, and even the outsiders. And then we characterize what are the artifacts for knowledge obsolescence. And we found that the major ones are APIs, programming languages, and references. We also want to highlight here that in the two different gray color, that the gray one are the knowledge that is no longer working, and the black one is the knowledge that is not recommended, which usually occur in legacy systems. And then we do a manual study to characterize whether these obsolescence observations provide supporting evidences. We found that the majority of them actually provide some kind of evidence. However, information such as version or time are not that much. For example, when people are providing a link, that link, although it provides the updated information, but the updated information can be obsolete again. Then at the last, we analyze these answers to see how well they are maintained, and we found that the majority of them are not actively maintained, even if people observe the obsolescence. For example, 20.5% of these answers are eventually updated, and only 6.3% have newer answers, and it takes 118 days for users to update or add answers. However, usually the maintenance activity occurs in the comments. This motivated us to conduct another study to analyze all the comments on Stack Overflow under these answers. So we found that the majority of these answers are actually very informative. For more details, you can refer to our follow-up study in the TSC 2019. So this was another work that's under the same scope of knowledge obsolescence and the knowledge decaying crowdsourcing platforms such as Stack Overflow. So at the last, we suggest that Stack Overflow should encourage the maintenance of the obsolete answers, such as by rewarding badges or reputation points. So to summarize this work, we know that the softwares are rapidly evolving, and we analyzed the obsolete answers. We found that more than half of these answers were obsolete when somebody posted them. And we found that the majority of them actually providing supporting evidences when they were posting the comment to point out the obsolete answers. However, these answers are not actively maintained. Thank you for your time. And if you have any questions, please feel free to ask me.
Thank you, Aoxiang, for your nice presentation. You are perfect on time. We have a question from the audience. Actually, there is this anonymous message. And the question is, based on your observation, do you have any idea how to detect obsolete answers automatically?
Yeah, so basically for some obsolete answers, such as references, it's very obvious. We don't need machine learning. You basically just detect if that link is valid or find this, the latest information. But for the others, such as APIs and something, you can leverage the comment. Maybe build a classifier based on those comments to find what types of APIs are more likely to become obsolete, because those are like usually not one occasions, but it can be one APIs is not maintained well. So over the time, it will just keep becoming deprecated.
Okay, thank you for your answer. Indeed, we received the other two more questions, but I think that we don't have enough time here. So you will find that question, and maybe the attendees can ask you directly in the next channel, in the lobby's video chat at the end of the presentation.
Yeah.
So next speaker is Fiorella Zampetti. Fiorella will present her work, whose title is An Empirical Characterization of Bad Practices in Continuous Integration. Also, this paper is a journal first paper, and there are a huge number of authors. Many of them are from my country, are Italian authors. So, Fiorella.
Okay, thanks, Giuseppe, for the introduction. Can you hear me?
Yeah, we can.
Okay, so I am Fiorella Zampetti, a postdoc researcher at the University of Sannio, and I'm going to show our results of our journal first paper entitled An Empirical Characterization of Bad Practices in Continuous Integration. This is a joint work with colleagues in University of Zurich and Zurich University of Applied Sciences. As we already know, continuous integration is a software development practice where members of a team integrate their work frequently with the main goal of identify integration errors as soon as possible. Previous literature has identified some benefits related to the adoption of CI, such as improvements in developers' communication, in developers' productivity, and also increases the customer satisfaction. At the same time, CI/CD adoption is challenging. Indeed, it is required a cultural shift, and sometimes it is required to have a fully automated test suite. Duval in 2007 has already defined a catalog featuring 50 patterns and anti-patterns related to CI adoption, but to the best of our knowledge, there are no previous studies aimed at investigating what are the bad practices that developers usually incur while using and maintaining a continuous integration pipeline. So by leveraging 13 semi-structured interviews and by mining Stack Overflow discussion related to CI topics, and once having applied a card sorting strategies, we were able to fill out a catalog made up of 79 CI bad smell, grouped into 7 different categories, dealing with with the management and the process and the CI process. Some of our results are able to confirm previous literature, such as it is a bad practice to have aged and unsynchronized branches, and at the same time also the lack of a stable release branch is felt as very predominant in terms of bad practices. On the other hand, some of our results are kind of contradicting previous literature. As an example, if we look at the setting up the right infrastructure, while this was felt as quite relevant when Yuval wrote his book, today this is not a big deal unless you are working on embedded software that requires complex and expensive hardware. Another kind of contradicting result is related to the adoption of Nile build. Indeed, while Yuval discourages et al. The adoption of Nile builds, we found that developers still use it for computational intensive testing and analysis. Some other smells are kind of not presented already in the literature. As an example, we found some smell dealing with the build script, like the abuse of shell script, the adoption of complex scripts, and more important, scripts that are highly coupled with the environment. Looking instead at the build outcome, one bad practice is related to poor build observability. In this category, we have smells such as build errors that are not clearly visible in the build, or failures notifications that are only sent to developers that explicitly subscribed. While looking at specific phases of the CI process, one of the relevant bad practice is related to skipping tests and quality checks with the main goal of having a successful build. However, we know that the main goal, if you adopt CI, the goal is to identify and fix integration error as soon as possible and not hide problems. In terms of static analysis tools, we found a bad practice dealing with failing to configure quality checks. Indeed, very often developers tend to use default checks, but default checks produce, of course, unneeded warnings and at the same time also miss relevant one. At the end, we have tried to identify some implication for different stakeholders. As an example,
you have 1 minute.
Okay.
1 minute, okay.
For practitioners, we suggest to not use out-of-the-box tool and also favor specific portable tools over hacking. In terms of researcher, we ask researchers to develop automated CI bad smell detectors, but also try to provide support for failure analysis. And as regard educators, we are suggesting to teach CI culture and not just CI technologies. That's it. I am ready for questions.
Thank you very much, Fiorella, for your nice presentation. I have a question. Actually, we have no question. I don't see any question in Slido. I see actually a counter that shows 2 questions, but I'm not able to see the text. Okay, now appeared. Okay. Can you conjecture why developers are switching off the quality checks? Lack of time, lack of awareness?
In some cases, it is possible that while they use default configuration, there are too many false positives and too many unneeded warnings. So in some cases, they tend to hide the problem, making the build pass. But in this case, the good practice is to properly configure static analysis tools.
Okay, thank you. So we have time for a second question. Sometimes developers put basic tests for themselves and therefore intentionally skip the test in further CI stages. Could you identify such?
One of our bad smell is related to properly structure test cases based on their objective. So you need to have a different kind of folders, for instance, in which you put different kind of tests, and in this case, you are able to properly select the subset of test cases that you want actually run in the CI, and tend to use the other one in your private builds.
Okay, thank you. In the meantime, we received an additional question, but we don't have enough time. So I suggest to join you in the lobby's videos chat in the next hours or minutes, maybe. So let's pass to the next speaker, that is Luis Cruz. Luis Cruz is there. So please activate the microphone. And the paper is to the attention of mobile software developers. Guess what tests your app? Also, this one is a journal first paper. Thank you, Luis Cruz, for coming.
Hello, everyone. Thank you for the introduction. So this is the work with Rui Abreu and David Lowe. And it was first published in the Empirical Software Engineering Journal. So if you're curious about this work, please take a look and read it. And I'm happy to follow up with any other comments and questions. So this work, it all started when I was doing my PhD on energy efficiency of mobile applications. And we wanted to see what were the testing practices of mobile applications so that we could build on top of that and create energy efficiency tests. So first of all, we wanted to see how the mobile application world was doing quality control in their applications. And so,
I'm sorry, can you start the presentation once again, because we have some problem with the refresh on the right side of the slide. In the presentation mode.
So what do you want me to do? Sorry.
Yeah, we see on the right side the edit master slide, so we are not able to see all the text you show in the slide. So you should restart the presentation in presentation mode. Okay.
Okay.
I'm sorry, but.
So, okay, I'm gonna share this once again, and I'll start
again.
Is it?
Yeah, no, it's the same. We have the same issue.
Okay.
Try to close the panel on the right side before starting the presentation.
Okay.
So unclick format.
Sorry, can you? So I should close which panel? This one?
Yeah, this one. Yeah.
So like this. This is.
Yeah, format. Okay, let's start the presentation, and if we are not able to solve the problem, okay, it seems that always work properly now.
Okay, it is working now.
Okay, it's fine. I'm sorry.
Okay. All right. So sorry about that. So we'll restart the presentation. So this is.
You can skip the first the first slides.
Okay. So the idea is that there are many mobile applications. Right now we have 3 million apps on Google Play, and if those apps have some sort of bugs, they can immediately lose popularity, and users may switch to another app. So this is a very competitive field, and bugs need to be taken into account. So typically the way we do this is by testing. And what we wanted to know was whether mobile apps are actually being effectively tested, especially because we wanted to build on top of that and do energy efficiency tests. The problem was that we were having trouble finding applications that actually were doing tests. So we decided to do a study where, okay, we didn't look into energy efficiency, we just want to know how the mobile apps are testing. And so we looked into the prevalence of automated testing technologies. We looked into the possible trends that could happen in the testing world. We also looked into this relationship between the testing and the popularity of the app. We wanted to know if there was any impact. We also wanted to look into testing practices and if there were actually code issues in the code. And also we looked into the relationship between doing tests and adopting continuous integration pipelines. So we collected as many as mobile apps as we could. And the easiest way to do this was by going into F-Droid and collect free and open source applications. Then we extracted their GitHub repository to be able to run our analysis in the source code. We also went to their Google Play page to collect popularity metrics. We ran SonarCode on top of the source code, and we also ran other static analysis tools And we also created our own to be able to understand what were the testing technologies being used and so on and so forth. And so here are some of the results we got. In the paper, we have many more. So if you're curious, please go and check the paper. So this was one of the simplest ones. We can see that, so here in the y-axis, we have the portion of mobile applications that that use particular technologies. So on the blue bar, in the first one, we combine all the technologies, and we see that only 41% of the apps are actually using any sort of testing, automated testing technology. And most of them actually use JUnit. And we see that, for instance, user interface tests are only being used by 15% of these apps, and cloud testing platforms are even not in the map. Only 3% of the apps we're actually using. So this is another interesting visualization we got from the data. So we are comparing the number of issues per file in the project with the type of issues that we can get when we have tests in the project and when we don't have tests in the project. So these blue boxes refer to projects with tests, and the red boxes refer to projects without tests. And we can see that
you have about 1 minute more.
Okay, thank you. So we can see that in projects that did not have tests, we could see more issues per file. And this is also another one we got. So the bottom line here is that only 15% of projects are using tests and continuous integration. And we see that, for instance, there are apps that there are still apps that have no tests, but they are actually using continuous integration, probably for static analysis. But we kind of see these big box of projects that actually have tests, but they have not yet adopted continuous integration. So we see kind of an opportunity here for these projects because usually continuous integration plays well with automated tests. And again, we see like a big box with no tests, no continuous integration, no. So we need to see what's happening here and call out for tool developers to see what we can do about the mobile applications, because obviously this is still a very green field for continuous integration. So based on all these apps that we were analyzing, we also decided to select the apps that were actually using all these, or at least trying to apply all these testing practices. So we created this Hall of Fame. Please check it out, and you can see really cool projects from the Android world that are actually doing tests. So it's kind of cool to see. And that's it. Sorry for the initial technical difficulties, and I'm happy to get your questions.
Luis, thank you very much for your nice presentation. Unfortunately, due to the issue we had at the beginning of the presentation, we have time only for a question. I hope in a short answer for that question. Is there a way to detect those anti-patterns automatically?
So yeah, so most of these best practices or technologies that were used, we were assessing it automatically. So either by using SonarQube or by creating our own static analysis tools that we have available in the repository of the paper. So yeah.
Thank you. If the attendee of that session has have other questions for the presenter, for Luis, please meet him in the lobby. Thank you again, Luis, for your nice presentation. Next speaker is Davide. Davide will present the last paper of that session. This paper is a technical paper, and it is this paper received an ACM 6 of Distinguished Artifact Awards. And I see the slide of Davide, but I cannot see Davide. So Davide, can you activate both the microphone and the camera?
The camera is on. Can you see me? I will turn it off and on again.
No, not yet. Yes, now yes.
Oh.
Okay.
Thank you. Hello, everyone. My name is Davide. I'm a PhD student at Delft University of Technology and a researcher at SIG in Amsterdam. And today we'll present a paper called Primers or Reminders, the Effects of Existing Review Comments on Code Review. So we all know how peer review of manuscript works. We all have done it at least once, and reviewing a manuscript is pretty similar to review code. So for example, they are both asynchronous. So the author submit a manuscript or some code to review, and the reviewers will asynchronously review the code or the manuscript and check for errors or stuff like this. Generally, reviews contain more than one reviewers. So in the case of a manuscript, it's generally around 3 reviewers. And for the code review, it's more or less 2 or 3 reviews, 2 or 3 reviewers. I've done a previous study, and I studied Eclipse, Qt, and OpenStack, and I saw that in average is around 3, and sometimes it can go up to 5 or 10 or even more. However, these 2 practices have one particular thing that is really different, and that is that in the case of a manuscript, the reviews are done independently from each other. So we all have done it, right? When we review a manuscript, we generally cannot see the review of the other reviewers until we submit one. And this is because we don't want to be biased with the other reviewers. However, in the case of a code review instead, reviewers can immediately see each other's reviews and can see each other's comments. And we ask ourselves, but aren't reviewers biased by reading each other's reviews? So in this paper, we studied availability bias. And availability bias is one of the cognitive biases we have. And it's the tendency to overestimate the likelihood of events with greater availability in memory. And in other words, when making a decision, we generally tend to consider memories that comes to mind easily and quickly, so recent memories. So when we do a review, when we do a code review, by reading each other's comments, aren't we like biased toward, for example, a bug type? And if so, maybe we should change how people do code review and take it to something more similar to, for example, how a manuscript review works. So reviewers don't see each other's comments until we submit one. And this is what we've done. So we studied availability bias. So what's the effect of priming a reviewer with comments during a code review? However, not all the bugs are the same during a code review. And so we split this main research question into 2. So what is the effect of priming a reviewer with comments of a bug type that is normally considered and is not normally considered? How did we do it? We ran a control experiment and with 85 developers. So first of all, they answered some demographics questions and co-founders. So like experience in Java, experience in code review. Then we split them in 2 groups, treatment group and the control group. In the treatment group, the reviewer had one comment from a previous reviewer talking about a bug, a specific type of bug. In the control group, instead, there were no comments. Then each group was split into 2 other groups, one for RQ1 and one for RQ2. So in RQ1, as I said before, we considered, we put a bug that is not normally considered. And in this case, we chose a null pointer exception on parameters. And this because both gray and white literature, we saw that a null pointer exception specific on a parameter is not normally considered during code review because, first of all, it's hard to catch at code review time, you only have a snippet of the code. And we generally expect the other developers to, well, not pass null pointer on parameters. For RQ2, instead, we consider a bug that is checked during code review, and this is algorithmic bug or corner case bug. And for example, Google code review guidelines specifically mention to check for this corner cases bug because they are very difficult to catch. So for example, what happens if you pass an empty list or an int max int, so integer overflow, etc. So no matter in which group they were, at the end, we asked them some question on the code review. So in the treatment group, we asked them, well, did you catch this bug because you were biased towards this bug type from the comment, or did you catch it without the comment? In the control group, instead, we asked them whether they catch the bug, and if they did not, why, according to them, it was hard to catch. To give you an example, this is one of the two patches, and as you can see, we are in the treatment group because there is a comment there from Pat Smith, and she's talking about some corner cases bug, and she's referring to that greater than 10 should be greater or equal, otherwise it will give some error. So we expect the reviewer reading this comment to check for other corner cases, and there is one, and it's here in this line. This should not be greater or equal than 0, should be greater than 0. So as you can see, we expect people reading a comment of a corner case bug to catch also this other corner case bug. However, they might miss this other bug that is hidden here, and this is a null pointer exception. So by priming a reviewer, reading a comment on a specific bug, we expect them to find more bugs of the same time and less bugs of the other types. And let's jump to the results. So we have two columns here. So this is for RQ1, the null pointer exception on the parameters. We have two columns, prime bug and not prime bug. So prime bug is, of course, the bug of the same type of the comment, and not prime bug instead is the other type. So we expect the reviewers that read the comment to catch more times prime bug and less time not prime bug. And what I've just said is half true. So that the people in the treatment group catch more times the prime bug, so the bug of the same type of the comment. However, this did not prevent them to find also the not prime bug. As you can see, it's not statistically significant.
Davide, 1 minute.
Yes, so this means that they found it the same amount of time. When I asked them, thank you. When I asked them whether they were influenced by the comment, they replied 40% extremely influenced, 40% very influenced, and 20% somewhat influenced. So to sum up, reviewers primed on a not commonly considered bug are more likely to find the same bug more times. However, this does not prevent them in also finding the other bugs. Now, if we move to the commonly considered bug, so the corner case bug, we can see that whether the comment is present or not doesn't actually influence at all the catching the same bug or the other side, the other type of bug. They catch the same amount of bugs whether they were influenced or not, whether they were primed or not. Whether they, when asked whether they were influenced, they replied 50% extremely, but 40% not influenced or slightly influenced. So in this case, we priming on an algorithmic bug, well, does not have an influence, and they did not capture fewer bugs of the other type as well. So to sum up, well, we saw that priming a reviewer on a bug that is not normally considered can act as a reminder rather than a primer. A reminder is something that, well, I did not think about this bug, and now that you remind me of this bug, maybe I will check for other types of this bug all over the code. But this does not prevent the reviewers to also catch the other bugs. So we did not find any statistically significant difference in priming the reviewers on a specific type of bug. So the way we currently do code review seems fine. And that concludes my presentation. Thank you very much.
Thank you, Davide, for your nice presentation. We have an interesting question for you. It concerns some threats that could be related to the experiment. Mm-hmm. In particular, let me read that question that is anonymous. Did the experiment instruction specifically ask subject to do review as they normally would, or will there be experimentation bias in their behavior?
No. So when we asked them to do the code review, we specifically asked, please do the code review as you would normally do. So check for bugs. And actually, when we provided them with the instructions, the review was not available. So they did not know the code. They did not know that comment was there. We just asked them, please do the review as you would normally do. It's Java code, and there is also a test. So it was as similar to a normal code review as possible.
Okay. We have time because your paper is a technical paper, so we have 4 minutes for question. We have 2 additional questions. The first one concern the second one concern threats to validity again. Could the simplicity of the task have influenced the outcome?
This is an interesting question.
Concern external validity threat. Yes.
So in after we have run the study, we have done it's called robustness testing. That is, we tried. It's also described in the paper, and the idea there was to try to see whether we failed in the experiment because, well, we did not find statistically significant difference. So it might be that our experiment was wrong. So we tried to demolish it with all threats as possible. But so as for this question, there is one specific paragraph on this, and we do not think it was too easy because 50% of the participants, well, around 50% of the participants found the bugs and 50% not. So it didn't seem too easy to find the bugs, but it also didn't seem too hard. And also, to participate in the experiment, you had to answer Java questions, and only if you answer correctly, you could continue. So we did not had random participants just doing random things. They really knew Java and how it worked. So yeah, we do not think this is the case.
Okay, for your answer. Unfortunately, we don't have enough time to answer the 2 additional questions we received in the meantime. So I would like to thank Davide and the other presenters once again. And let me share with you the final message from the organizer. That is, look for the presenters of this session in the lobby's video chat during the 3rd hour. We encourage you also to visit the SRC posters and the demo session and attend the Ask Me Anything session with Bashar Musibeh. I hope that you will enjoy the rest of the conference, and I thank you again to have attended the A10 session and the Human Aspect 2 session. Thank you very much. See you in presence for the next edition of the conference in Madrid. I hope so. Thank you again.